Hello, welcome back. I thought today I'd have a look at amplifier harmonics on a valve amplifier, and this amplifier is the Leak Stereo 20, which I restored about a year ago, and it produces a maximum 10 watts before you encounter distortion. So having just acquired a new piece of test equipment, which I shall show you, it is this scope, GW Instek MDO 2102A. I think I might turn that off. Well, no, that doesn't help, but we get a bit of reflection. And the reason I bought this was I was watching X-Ray Tony B, who's got a very popular channel repairing and restoring old hi-fi equipment, and he has far more knowledge than me and far more equipment than me. And he'd recently bought one of these things, and the reason he bought it was, well, one of the reasons, it's got a built-in spectrum analyser. Now, it's a mixed domain oscilloscope, hence the MDO in the beginning of the model number. So, it will, it's got a spectrum analyser. Now, I've already got a spectrum analyser, an RS spectrum analyser, but RS spectrum analysers rarely go below 9 kHz, which is fairly normal. I mean, I did have a very old HP at one time. With the right plug-in, would go down to it would go down to audio frequencies. Yeah, it would go to audio frequencies. Anyway, this one's specified to go from DC to 1 GHz. The spectrum analyzer function on this, and I don't want to use it up at the high ends. I just want it for audio purposes, and having played with it, it seems to work fairly well, but we'll get into that later. So if I just turn on my signal generator, and the amplifier's warmed up already, and as usual I'm using a dummy load with various connections to it, 2 scope probes, and a cable going up to the HP audio analyzer, so I can monitor the distortion and also the power output. So back over to the scope, and get it on the screen. I wish I didn't have that reflection there. I wonder where that's coming from. Hang on a minute. So I had to turn the main light off, otherwise you get far too much reflection on the screen. And I'll turn the signal on to the amplifier now, and we'll see what we get. So I'm monitoring both channels, although I should only be testing on the yellow channel when it comes to doing spectral analysis. And I've had to go, let me go up to the audio analyzer, and that is reading power, so that's 10 watts, which is what the amplifier is specified at. It will do a bit over 10, it will do about 11, but the difference between 10 and 11 is insignificant. You certainly wouldn't hear that. 10 watts is more than enough for me, especially with my big speakers. So that's what the power is coming out, and we just test for distortion, and we're 0.13%, so that's not too bad, although nowhere near as good as I've seen on transistor amplifiers, but 0.13 is fine. So now go back to the scope again, and I want to do spectrum analysis, right? look at the spectral content with a 1 kHz signal going in. So first of all, I think we need to know how good the signal source is before we do that, because the amplifier is only going to amplify the signal you stuff into it. So if you've got a poor harmonic content on your signal source, then you're wasting your time, aren't you? But my Rigel function generator seems to be pretty low on distortion, but we'll look at it anyway on the spectrum analyzer. I mean, I could use the HP audio analyzer signal source, but that seems just about the same distortion levels, so the Rigel's more easier to use, and so on and so on. So I'm going to turn the amplifier off and reconfigure. Okay, so now I've got the signal generator connected up instead of the amplifier output, and because this has been set up for a ×10 probe, the readings will be all wrong, but that's not the point. I'm not trying to measure the voltage as such, I'm trying to measure the spectral content, or how the harmonics compare to the fundamental. So in order to do that, I have to select option, then I get one called spectrum analyzer, and there we are. That's what your spectrum analyzer looks like. And there's the pointer. I need a pointer. My kingdom for a pointer. So there's your main peak at 1 kHz. This is set to have a span from, let me see, starts at 1 Hz, stops at 20 kHz, and this thing is so cumbersome to set up. That's my only real criticism with it. Of course, it needs a keyboard, but there is no room for a keyboard on this machine, because although there's a big space on my model, that would be for the 4-channel model where you'd have the controls for that. So no keyboard makes this thing hard to set up. So if you want to set something like the start frequency, you get a list of these options, 1 Hz, 10 Hz, and you can go down them and whatever. But if you want to set something different to that, you've then got to press select and modify each field on this to get what you want. Really cumbersome and annoying, but it is what it is. And the other thing's a bit annoying is you get all this stuff at the bottom which you can get rid of, because it's impeding me seeing the spectrum down here. So if I press do that, you see now I get a nice clear spectrum, and we've only got one marker, which is a green thing up there, right? And there's no way to move that marker. It just seems all it does is adopt the highest peak it can find, and it stays there. I can't move it, I can't do anything with it. I can't bring up another marker. I have no marker functions like peak or delta function where I could move a marker to the next, down to a harmonic or whatever. But it's the best you're going to do with it, it seems. It's a basic spectrum analyzer, but it seems to work quite well. The other thing which is hard to get used to is at the moment it's showing me that marker as 1 kHz and it's 16 dBs a volt. And coming from a world of dBs, milliwatts, it's hard to get your head around dB volts. But it's the only way to measure a logarithmic function on a display like that. You can set it to linear mode where it'll measure the voltage, but then you haven't got the dynamic range because you've got 10 dBs per division, although you can set that to other things if you want, like right, if I set it to amplitude, I could set it to 20 dBs division, but I don't want that. I want 10 dB. I like 10 dB. I've always been used to using that. Also, you can also set your position of the well, your sensitivity. The other thing you have to be careful with this is going back to scope mode. You've got to make sure you don't overload the front end on this, otherwise you'll get misleading reasons on the spectrum analyzer. So we're back to that again, and what I want to do is get the most dynamic range, so I'm going to try and move that 1 kHz marker up the screen a bit, as far to the top as possible. Okay, and now we've still got 16 dBs a volt, which is wrong because I'm not running it in times 10. I'm sticking it. It's thinking I've got a times 10 probe on it, but that's not the point of this. The point of it is looking at the relationship of the harmonics. So now if I go to, and the only way to measure it really is to use the cursors. So I bring up cursors, and I now get a box which virtually obscures my main tone, which is really annoying, and I've got 2 cursors, and so if I press select and move that, what I want to do now is get that on the 1 kHz. And it's hard to see, other than the fact that you want to try and match that reading up there with that one down there. So now I've done that, 16 dBs a volt. Fine. So now we can see the harmonics down here, and they're really quite low in the noise level. But if I do select again, I can move my other marker, which is, or other cursor, which is there, and I can stick it, say, on that one. Looks like 2 kHz, second harmonic. Alright, so now it's telling me as best it can. It's jumping around a bit, which is annoying. Okay, well, according to this, my second harmonic is 57 to 60 dBs down on my fundamental, because that's delta. That's showing the delta between the two. Delta is 1 kHz because you're between 1 and you're on 2 kHz, which is, yeah, whatever. And the delta, in other words, relationship in dBs between cursor 1 and cursor 2 is around 60 dB. So that's a pretty low level of harmonics coming out of my signal generator. And if I try and move it, say, to the next one, which will be 3, and that was measuring -59, something like that. So they're close to the noise floor anyway, which is all we need to know, that we've got a pretty good spectral purity coming out of the signal generator. So now I think onto the main test would be to do the amplifier. So here we are with the amplifier now connected. That's the output on one channel only. I'm really going to test one channel, and so I've got 9 volts RMS, which equates to 10 watts RMS into 8 ohms according to the HP audio analyzer. It's saying 10 watts. 9 nines are 81, divided by 8 is 10 watts, yeah, that sounds fine. So switch over to spectrum analyzer, and here we are. So if I get rid of all this, gives you a clearer view. So you can see your main signal up there, and it's telling me it's 18.8 dBs a volt, which is a bit alarming, confusing, because I'm used to dBm, of course, but I'm sure that works out at 9 volts or RMS or whatever I was reading. I think it involves log 20 and all that stuff when you do voltage. Well, I know it does, to power. So that obviously is second harmonic, 2 kHz, and third and fourth, but the only way to do it properly is to get the cursors up, which I shall do. Right, cursors. Move this one till it sits on the 1 kHz, and the main thing to do is to make sure the reading on cursor 1 is 18.8. It's the same as what you've got down here, 18.8, so you know you're on the peak. So now I can bring my other cursor over here and move it down to 2 kHz. So that was before, so that's 52 dBs down on the fundamental. Look at that box there with a triangle. That's, and obviously the spacing is a kilohertz, but it's 53 dBs down. So I was measuring before 60 dBs down on the signal generators spectrum. So it's obviously slightly worse than the pure input from the generator. But anyway, we'll move it across a bit and see what number goes in. Third harmonic looks like, and that one is 56 dBs down on the fundamental. So I was getting 58 roughly from the and it's varying a bit, 55 whatever. So before I was getting 58 dBs down, so there's hardly any difference. So it's really not introducing much distortion at this point. And I switched to, if I switch to distortion on the HP audio analyzer, it's measuring 0.12% at the moment. So there you go. But I wonder what happens if I overdrive it slightly beyond its 10 watts. So I put it back to the time domain rather than frequency domain, and I increase the input signal a bit till I get a bit of distortion there. And what am I reading on the that's reading 13 watts now. It's a little bit too high, I think. Don't want to run it like that. It's difficult. .9. I'll have to do, I don't know if it does it any damage overdriving it like this, probably not. So go back to spectrum analyzer, and the fundamental's gone up to 20 dBs dBs a volt. But if I just get rid of all this stuff a minute, you can see how the harmonics have gone up considerably now, just by overdriving it slightly. And the distortion I'm getting at the moment is nearly 1% on the HP. So let's try and have a look at the harmonics. So that's the second harmonic. That's gone down to, well, that's increased to 51 dB where it was 60, so we've gone up considerably there. But it looks like the third is, or the odd harmonics look the worst ones. And that's the third harmonic, 3 kilohertz, and that is now 45 dBs down on the fundamental. So that's gone from 58 to 45, so it's considerably worse, as you'd expect if you're going into distortion. I can move it along. 4 kilohertz doesn't seem to be bothered at all, and we've got one here which will be 5 kilohertz. That's 48 dBs down, and so it seems like the odd harmonics are the worst ones. Even harmonics don't seem to be bothered at all by overdriving, which I think is a characteristic of valve amplifiers, but I'm no expert on valve amplifiers. So that one is actually at 7 kilohertz, and that's 46 dBs down. Okay, so that gives me an idea what it's like to overdrive an amplifier, a valve amplifier. Turn the signal level down again. Don't like overdriving it too long, and as you can see, turn the cursors off, all the harmonics have gone back down again. And we're now measuring 0.12% harmonic distortion on the HP. So that's about it really for measuring that. Other thing I wanted to do was to look at the lower end of the frequency band to see if there's any 50 Hz or 100 Hz. So I just reconfigure. It's too much hassle messing around with all this. Without doing this test, I will just turn off the signal. I don't need a signal, I just want to see if there's any 50 or 100 Hz present. So that took a hell of a lot of reconfiguring, but here we are. We're now sweeping between 1 Hz and 1 kilohertz, and as we can see, we've got a load of peaks here. And ignore this rubbish here, it's settled on the 0 point as its strongest signal. I'll bring up the cursors and peak on that one here. That's about as good as I'm going to get it. Minus 51. So that's minus 51 dBs a volt, and that's at 50 Hz. So that's interesting, isn't it? Minus 51. I haven't a clue what that means. It's probably in the millivolt range. So try another cursor, and that'll be next one is the 100 Hz, second harmonic, 50 obviously, and they seem to extend all the way up to 50. So again, it's I think it's odd harmonics it's picking up. So, but we're right down in the noise here. This is a very low level, and that one's at 350 Hz. If I go back to the time domain, you can see what I'm looking at, and I'm on a range of 20 millivolts per division here, so that's we're looking at 6 millivolts RMS of 50 Hertz. So there you go. I think that's the end of all this. And my only criticism is I wish they'd have made this easier to use, this device in the spectrum analyzer mode. I mean, if they could have made it a touch screen with a keyboard, that would have improved things considerably. But all in all, I think it works quite well for seeing all the harmonics I could never see before down at the low audio frequency range, or in the audio spectrum anyway. So that's about it really, I think. So it's time, I think, to disconnect all this and put the leak back in the lounge where it belongs. I hope you enjoyed it and got something out of it, and thank you for watching. Bye for now.